Welcome back. In this lesson, we're looking at supervised learning explained simply with real-world examples. AI/machine learning educational explainer. Now let's look at learning with correct answers. Imagine teaching a student with solved examples. You show the question. You also show the correct answer. After seeing many examples, the student learns the pattern. Supervised learning works in a similar way. The model learns from data that already has answers. In this video, we will explain supervised learning using real industry examples. Now let's look at roadmap of the video. First, we will understand what supervised learning means. Then we will learn what labeled data is. Next, we will explain features and target values. After that, we will cover classification and regression. Then we will look at real-world examples from banking, healthcare, retail, manufacturing, and logistics. Finally, we will discuss benefits, limitations, and responsible use. Now let's look at what is supervised learning. Supervised learning is a type of machine learning. It trains a model using examples with known answers. The model studies the relationship between input data and the correct output. After training, it can make predictions on new data. For example, it can learn from past loan applications. Then it can predict whether a new loan application may be risky. The key idea is learning from examples with correct answers. Now let's look at labeled data explained. The known answer in supervised learning is called a label. A label tells the model what the correct output should be. For an email, the label may be spam or not spam. For a house, the label may be the actual sale price. For a medical scan, the label may be normal or abnormal. The model learns by comparing its prediction with the label. Better labels usually lead to better learning. Now let's look at features and target. In supervised learning, input columns are called features. The answer we want to predict is called the target. For house price prediction, features may include size, location, rooms, and age of the house. The target is the final house price. For customer churn prediction, features may include usage, complaints, payments, and service history. The target is whether the customer left or stayed. Features are the clues, and the target is the answer. Now let's look at how the model learns. The model starts by making predictions from the training data. At first, many predictions may be wrong. The model compares each prediction with the correct label. The difference is called error or loss. The model adjusts itself to reduce this error. This process repeats many times. Over time, the model becomes better at prediction. Now let's look at classification and regression. Supervised learning has two major task types. The first is classification. Classification predicts a category. Examples include fraud or not fraud, approved or rejected, churn or no churn. The second is regression. Regression predicts a number. Examples include price, sales, delivery time, or temperature. So classification predicts classes, while regression predicts values. Now let's look at banking example, fraud detection. In banking, supervised learning can help detect fraud. The model is trained on past transactions. Each transaction has a label, fraud or not fraud. Features may include transaction amount, location, time, merchant, and customer behavior. The model learns patterns that appear in suspicious transactions. When a new transaction happens, it can assign a fraud risk score. This helps banks stop fraud faster. Now let's look at healthcare example, diagnosis support. In healthcare, supervised learning can support diagnosis. A model can be trained using historical patient records or medical images. Labels may show whether a condition was present or not. Features may include symptoms, lab results, age, medical history, or scan patterns. The model can help identify patients who may need attention. But the model should support doctors, not replace them. Human medical judgment remains essential. Now let's look at retail example, customer churn prediction. In retail and subscription businesses, supervised learning can predict customer churn. Churn means a customer stops using a service or stops buying. The model learns from past customers who left and customers who stayed. Features may include purchase frequency, complaints, discounts, app usage, and support history. The target is churn or no churn. Businesses can use this prediction to offer support before customers leave. This helps improve customer retention. Now let's look at manufacturing example, quality inspection. In manufacturing, supervised learning can help detect product defects. The model can learn from images or sensor readings of past products. Each product may be labeled as good or defective. Features may include image patterns, machine readings, temperature, pressure, and vibration. The model can flag products that may fail quality checks. This helps reduce waste and improve product quality. It can also support faster inspection. Now let's look at logistics example, delivery time prediction. In logistics, supervised learning can predict delivery time. The model learns from past deliveries and their actual delivery durations. Features may include distance, route, traffic, weather, vehicle type, and delivery location. The target is the actual delivery time. Once trained, the model can estimate delivery time for new shipments. This improves planning and customer communication. Better predictions can reduce surprises in operations. Now let's look at sales example, demand forecasting. Supervised learning can also help forecast demand. A model can learn from past sales data. Features may include season, price, promotions, holidays, location, and previous demand. The target is future sales volume. Retailers can use this prediction to plan inventory. Manufacturers can plan production better. Supply chain teams can reduce stockouts and excess inventory. Now let's look at training, testing, and evaluation. A supervised learning model must be tested before use. Usually, historical data is split into training data and testing data. Training data teaches the model. Testing data checks how well it performs on unseen examples. For classification, we may measure accuracy, precision, recall, and F1 score. For regression, we may measure error between predicted and actual values. Evaluation helps us know whether the model is reliable. Now let's look at benefits and limitations. Supervised learning is powerful because it learns from real examples. It can improve speed, consistency, and decision support. It works well when we have good historical data and reliable labels. But it also has limitations. Bad data can create bad predictions. Biased labels can create unfair outcomes. The model may fail when the future is very different from the past. That is why monitoring and human review are important. Now let's look at final recap. Let us recap the full idea. Supervised learning learns from examples with correct answers. Features are the input clues. The target is the answer we want to predict. Classification predicts categories. Regression predicts numbers. Industries use supervised learning for fraud detection, diagnosis support, churn prediction, quality inspection, delivery planning, and demand forecasting. If this helped, like, share, and subscribe for more simple AI and machine learning explanations. To wrap up, here is the key takeaway. You now have a structured overview of supervised learning explained simply with real-world examples. Review the core ideas, connect them to examples, and revisit concepts like learning with correct answers. Roadmap of the video: what is supervised learning? When practicing. If you can explain the idea in your own words, you have really understood it.